In this video, I'll show you how to generate plots for quantile treatment effects. Let me first go get the data. To run the program, I come down to the button that says Quantile Plot, which is right there. When I click on it, a set of instructions for how to use it appears in the description box. And then down here is the input box where we input information. Because this uses data, I'm going to have to go get the data. So I click on Choose File to find the file where the data is located. The data is quant95r.txt. And this box here shows the variables that are in the data set. This is very important because variables in R are case sensitive, and we're going to be entering some of the variables over here in the input box, so it's very important that you respect the capitalization, and this is a very good reminder. Up here, I'm going to put the folder where the data are located, as well as the file name again. And we have to do that so the program knows where to find the data file on your computer to execute the analyses. Okay, before we start, let me describe the study that I'm going to use to illustrate this. The study has an outcome variable that is a person's behavioral commitment to living a green or environmentally respectful lifestyle. It's measured on a 0 to 100 multi-item scale 3 months after the intervention, and it reflects a multivariate index of green behaviors the individual has performed in the past 3 months. It's variable Y over here. A two-group intervention was implemented. The treatment condition is in the dummy-coded variable treat, T-R-E-A-T here. 1 is the intervention group, 0 is the control group. Now, this program can be used to plot a cumulative distribution function for a single group or for two groups on the same plot. The latter is used to illustrate graphically what is known as a quantile treatment effect. Quantile treatment effect is the quantile value difference between the treatment and control groups at the qth quantile for a given outcome or mediator. For example, it might be the quantile difference for the median, which is the 50th quantile, or it could be the quantile difference at the 20th quantile, or the 80th quantile, or whatever. It allows us to see if the intervention effect varies depending upon what portion of the distribution you are looking at. Either the lower portion, say the 10th quantile, the middle of the distribution, say the 50th quantile or the median, or the upper portion of the distribution, say the 80th quantile. The analysis of quantile treatment effects can reveal these kinds of differences. Okay, let's run the program and then I'll walk you through the interpretation of it. Up here in this box, I want to put the variable that I want to plot, and it's going to be the outcome variable Y. I'm going to show you two groups, so I enter the number 2 here. The name of the grouping variable is the intervention condition, which is treat. And I have two values, 1 and 0, and that's all the information we need. I'm going to hit register input so that my website generates the R syntax for you. You click on copy to the clipboard. You start R. And up here on the left, I'm going to hit Control V, which will paste the syntax. And when I do, the program will automatically run. Okay, the program generated a plot, which we'll look at in a few minutes. And it also gives you information over here. The output is in blue and the syntax is in red. So we want to concentrate on what's in the blue. This is the sample sizes for the two groups. That's straightforward. This lists quantiles, actually deciles in this case. So this is the 10th quantile, the 20th quantile, the 30th quantile, and so on up through the 90th quantile. This is the group 1 quantile value. This is the group 0 quantile value, and this is the difference between the two. So for example, if I focus on the median behavioral commitment score for the intervention group was 50.8, and the median behavioral commitment score for the control group was 31.8. And the difference between those two is 19.02. And so it looks like the intervention is having an effect on the medians. If I look at one of the lower quantiles, for example, the 10th quantile, this is the score on the behavioral commitment variable that cuts off the bottom 10% of the people from the top 90% of the people. So the bottom 10% of people had a score of 33.33 or less, and that's in the intervention group. And in the control group, the bottom 10% cutoff was 19.21. And the difference between those two quantiles is 14.12. So the people that were in the lowest 10% for the intervention group, they had commitment scores of 33 or lower. And the cutoff for those in the control group was a lot lower. To define the lower 10%, it was 19. If we go to the upper end of the distribution and we look at, say, the 80th quantile, then the cutoff score for the 80th quantile for the intervention group is about 64, and for the control group it's around 41, a difference of about 23, give or take. So this means that the cutoff score that defines the top 20% of the distribution in the intervention condition was about 64, and in the control group it was only 41. Now the program provides a plot that I think is very informative and very useful to look at. But before I walk you through the plot, let me show you an example plot outside the context of this example. Now this figure plots the quantile value for different quantiles, called tau, for the treatment group, which is in blue, and for the control group, which is in black. And essentially these are plots of the cumulative distribution functions for each group. I've extended lines at the points that correspond to the 20th quantile, the 50th quantile, and the 80th quantile. And I've done that in both graphs. Now if I move to the right from a given quantile, like 20th quantile here, where the line intersects the CDF curve, if I extend a line downward, I'll get the value of the quantile. And in this particular case, the value is about 2.15. If I do the same up here at the median and extend it down, I'll see that the median is approximately 3. And up here at the 80th quantile for the control group, if I extend it down, I'll see that the quantile is about 3.84. And I have a similar plot for the intervention group. Now the quantile treatment effect, or the effect of the intervention, is represented by this dashed line in between the control group and the treatment groups. The wider this gap, the stronger the treatment effect. Now, if you look carefully at this graph, you can see that the width, or the magnitude of the treatment effect, is about the same at all the different quantiles depicted. So this width is about the same as this width, which in turn is about the same as this width. So this is a case where we have roughly equal treatment effects across the distribution. If you look over here on this graph, that's not the case. Notice down here at the 20th quantile, the width or dashed line is very small. And then up here at the median, it gets larger. And up here at the 80th quantile, it gets larger yet. And that's indicative of a case where the treatment is having a much larger effect at the upper end of the distribution than in the middle of the distribution than at the bottom of the distribution. So what we want to do is see if our plot looks more like this or if it looks more like this. So here's the plot that we observed with the control group in orange and the treatment group in green. And you can see it has the pattern where the difference between the two curves at the lower quantiles is a lot smaller than in the middle of the distribution. and they're widest at the upper end of the distribution. So in this example, the intervention is tending to have a larger effect for the portion of the distribution where people already are fairly committed to having a green lifestyle, and it's not nearly as effective at the lower end of the distribution where commitment is low. This obviously is very useful information to know when you evaluate the effects of your intervention, and it gives you much more information than just looking at the mean differences between the two groups, because that would mask this particular scenario where you're getting differential effects at the lower and upper portions of the distribution. Okay, in addition to plotting two groups, you can also generate a plot for just one group using this program, but doing so is really straightforward, so I'm not going to go over that here. So I'll close out R and come back up here, and that's it. Thanks a lot.